A team ships a nightly large language model, or LLM call that summarizes support tickets into JavaScript object notation, JSON. The prompt is one line: summarize this ticket and include the priority. On Monday, it returns 3 bullet points. On Tuesday, it returns a friendly email draft. On Wednesday, it invents a priority called medium-high, which the database does not allow. Nothing is malicious, nothing is dramatic. The model is doing what vague instructions invite, filling gaps. The bug is not that the model is creative. The bug is that the prompt is not a specification. The beginner version of prompt engineering feels like talking to a helpful person. Please analyze this. Make it better. Give me the key points. That works in a chat window because you can correct the model after it answers. It breaks in software because the next step expects something specific. A parser expects valid JSON. A workflow expects one of 4 labels. A human reviewer expects the same reasoning standard each time. Ambiguity in means variance out. If you do not say what the inputs are, what job to perform, and what output shape to return, the model will choose those details for you. Sometimes its choice is fine. Sometimes it becomes a production bug. Here is the core idea for this prompt engineering tutorial. Clear task instructions are specifications, not conversations. A good prompt says one job, names the inputs, names the expected output, and removes creative interpretation where the downstream system cannot tolerate it. This does not mean your writing has to be stiff or huge. It means the important parts are explicit. The test is simple. Run the same prompt twice on the same input. The answers may not match word for word, but they should agree on substance. If one run says refund eligible and another says not eligible, you do not have a model personality problem. You have an unclear spec. Build the prompt in 4 moves. First, write the task as a single verb phrase. Classify the ticket, extract invoice fields, rewrite the paragraph. Not classify and summarize and recommend policy changes. Second, list the inputs by name. For example, ticket text, customer plan, policy excerpt. Third, define the output. If code reads it, use a schema. Priority is low, normal, high, or urgent. Reason is a short string. Confidence is a number from 0 to 1. Fourth, add testable rules. Use only provided policy. Return error if policy is missing. Do not add fields. Then call the model through whatever application programming interface or API your provider uses and validate the return text. Let's make this concrete. Suppose you are building a tiny support ticket classifier on your laptop. The vague prompt is, read this ticket and tell me what to do. That can produce advice, empathy, a checklist, or a label. The spec prompt is, classify exactly one support ticket. Input, ticket text. Output, valid JSON with category and urgency. Category must be billing, login, bug, feature request, or other. Urgency must be low, normal, or high. Base urgency only on customer impact stated in the ticket. If the ticket lacks enough information, use normal and explain why. Now rerun it twice with the same ticket. I was charged twice and cannot access my account. Both runs should land on billing or login only if your rules define which wins. A few traps still catch experienced teams. The first is hiding 2 jobs in one prompt. Summarize the ticket and decide whether to refund. Those have different success criteria. Split them unless the output truly needs both. The second is overlapping labels. If billing and account access can both fit a double charge login issue, the model has to guess. Add tiebreak rules. Third, examples can contradict instructions. Models often follow examples strongly, so stale examples are dangerous. Fourth, setting temperature to 0 can reduce phrasing variance, but it does not repair an ambiguous task. My opinion, clarity beats parameter fiddling almost every time at this stage. This skill sits under almost everything we will build later. Tool calling needs clear instructions because a tool has a name, arguments, and failure modes. Structured outputs need schemas because your code cannot safely parse vibes. State and memory need fields because an agent has to know what to carry forward and what to ignore. Retrieval augmented generation, or RAG, needs grounded instructions because retrieved context can be partial or noisy. An agent is not one magic prompt, it is a harness around model calls: goal, role, tools, permissions, state, termination, and checks. Today's prompt spec becomes the smallest reliable unit inside that harness. Here is a safe 10-minute exercise. Use 5 notes from your own machine, meeting notes, fake support tickets, or short paragraphs you write yourself. First, create a vague prompt. Summarize and categorize this. Run it twice on the same note and save both outputs. Second, rewrite it as a spec. One job, named input, fixed output fields, allowed labels, and rules for missing information. Run that twice. Do not connect to third-party systems. Do not use private customer data. Your scorecard is simple. Do the two runs agree on substance, and could a small checker verify the fields? 3 beats to keep. First, write a spec, not a chat. One model call should have one job, unless you can explain why combining jobs is safer. Second, name the inputs and the output explicitly. The model will fill gaps, so do not leave gaps you care about. Third, test the prompt by rerunning it. Disagreement is evidence, not mystery. In the next episodes, we will turn these specs into structured outputs and tool calls. New Agent Foundations episode daily. If you want the paid libraries, templates, and deeper production examples, they are at islabs.ai. Build agents the reliable way, one reliable call at a time.